In this question, it is given that 1 gram of ice at 0 degrees Celsius is converted into steam at 100 degrees Celsius. The amount of heat required will be. So we can just consider it as like part by part. So we can consider that in the first case, it was something like ice at 0 degrees Celsius. So ice at 0 degrees Celsius, we cannot directly convert it into steam. We need to observe it by step. So first this ice at 0 degrees Celsius will convert it into water at 0 degrees Celsius. So we can write the first process ice at 0 to water at 0 degrees Celsius. Then what will happen? This water at 0 degrees Celsius will converted into water at 100 degrees Celsius. So you can write the next stage, that is water at 100 degrees Celsius. Then the next stage is water at 100 degrees Celsius will converted into water at it is converted into steam at 100 degrees Celsius. So you can write this is going to convert it into steam at 100 degrees Celsius. So our aim is to find out what about the total amount of heat energy for each process. So for the first process, this one we'll use that equation. Q is equal to, or take it as Q1, which is equal to m into L, mass into latent heat, or latent heat of fusion. Here there is no change in temperature, so we'll use this equation, m into latent heat. And in second situation, take it as this is Q2, which we can take it as nothing but there is a change in temperature, so we should use this equation, m as delta T. And in the third case, there is a transfer of or change in state without change in temperature, so we'll use this equation, m into from liquid to gaseous state, so we'll use latent heat of vaporization. So the net amount of heat energy will be equal to sum of all these energy. So we can write the value of Q1 is nothing but m is 1 gram, and latent heat of fusion for ice is, it's not given in question, but you should remember that it is equal to 80 calorie. And the value of Q2 we can take it as m into specific capacity of water is 1, and delta T we can take it as it is 100 change in temperature. In the third stage, that is take it as Q3, we can write mass as 1, and latent heat of fusion, which is given in question, that is 536 calorie. So it is given in question, so we are writing 536, otherwise we will take it as 540 approximately. So we can write the value of total amount of heat energy will be equal to sum of this, that is 80 plus 100 plus 536. So we can write this is equal to 6, and this is 11, so 1, and we can take it as this is 7. So we require a 716 calorie of heat energy.